So the title of this talk is Automated Subject Indexing, although with this we also refer more broadly to classification, but we do focus more on identifying topics and themes or keywords, or so to say, which can also be represented by classes. And it's state-of-the-art and evaluation, which is to be addressed in 4 main sections. In the first one, the background, which is also the longest one, we will look at key concepts, the reasons for why we could use automatic classification or indexing, and what are major approaches. Then 2 shorter sections will be some of the challenges and implications of those challenges. And finally, we will look at a concrete case study where we conducted research using geodecimal classification based on Swedish library catalog records. So let's start with the background. Why do we want to use automated topic identification more generally? Well, certainly to tag various content or products using categories or keywords or tags. We'll especially talk about applying this in the LAM sector or the GLAM sector, but certainly also e-commerce, news agencies use keywords to add them to their news stories. Blogs come with automatically included software that allows tagging or keyword adding. Directories of web pages used to be more common before, but there are some still today. Very interesting topic, and that's really been used quite a lot, is classifying topics and opinions from social media, and are used effectively for disaster prevention, for election prediction, as we have heard in media. Also, automatic topic identification is used in marketing. We can classify users based on likes, based on reviews and posts on different forums which they make. And the one that we use on a daily basis quite efficiently is email filtering for spamming, for filtering out spam. And many of these are done automatically. Now, going more closely to the topic of various information services, such as those used in libraries, museums, and archives, if we offer such a software, who could use it? Well, certainly it could be the subject librarians or the indexing catalogers during their indexing processes to fasten it, maybe make it more consistent, indicate some terms they would not have thought of. But also, it could be in university repositories of academic papers. It could also be authors creating original metadata, also to help them. Related to this, if services allow this, if they allow some kind of tagging by end users, which comes with its disadvantages, but research has also shown that if we provide social tags or suggestions semi-automatically for end users to choose from established control vocabularies and classification systems, then actually they do a much better job. They're happy with it, the users, and they assign more precise topics, more specific rather than general ones, because they're offered to them. And it helps them with focus for tagging, as this one piece of research has shown. And all this certainly helps with us maintaining the bibliographic objectives of our systems, which are pretty much endangered with the streams of digital documents coming our way. But in addition to helping with the scale and sustainability, it is also helpful to enrich bibliographic records with controlled vocabularies that we don't normally have. It's also to establish more connections across resources to connect better and more efficiently once we have them. And all this certainly to improve information retrieval. But also relevant here in the context of information literacy, for example, large public libraries who have users who are conducting serious public inquiry, for example, using open governmental data, or even working with sets of data themselves. It is also important that we as librarians are aware that we can train them about that as part of our data or information literacy programs. So here it would be good to mention that for research purposes, and certainly for university libraries, but even other libraries, it is good to make users aware about ways to create word clouds, named entity recognition, meaning to extract automatically names of persons, places from documents, sentiment analysis, like the ones used for election prediction, for example, or topic modeling. An example of topic modeling is seen here, and this is a bit of research conducted by Blay in 2012, where we see that he extracted most topics most commonly found together in almost 2 million articles from the New York Times. This is then helpful to summarize, visualize, explore, and theorize about a data set, which would normally be almost impossible to do manually. Then we can also look at the archives and historians who prepare demographic data analysis transcribed from census books, parish records, and city directories, who also then classify individuals by gender, age, occupation, place of birth. Or even more common are semantic nets. So linguists, literary scholars, social scientists might classify words occurring in a text by semantic category, organizing them into semantic web nets, as we see here an example of characters from Hamlet. And the one next is sentiment analysis from one of the many Trump's social media analysis reports. Now that we have seen how we can apply, in what kind of context, different ways to automate identification of topics, let's look at the very basic processes. What is really at the bottom of doing automatic subject indexing or classification? Usually there are three main processes. The first one is known as tokenization, and really it is simply creating a list of words or phrases if we decide to do phrases. That means taking away punctuation and spaces from, say, a book, and instead have just a list of words. After that, often conducted is stop word removal. Stop words are words which don't carry a lot of semantic meaning. So those words that don't really tell us a lot about what the text is about, like conjunctions, determiners, and so on. And then we're left usually with nouns, adjectives, and verbs, which usually carry some content. Depending on the language, often conducted can be stemming, which is reduction to a word stem. For example, computer, computing, and computers are really all related to the very same concept. And then in order to count all these words as belonging to the same concept, rather than counting them separately, we conduct stemming. Let's take a look at an example. This is a very short document, but if you want to classify tweets from Twitter, they will also be rather short, but mostly this is short for example purposes. The text reads, in theory, there is no difference between theory and practice. In practice, there is. So which tokens do we have here, and which stop words would we leave out? The token is everything that's in a rectangular, and stop words are all rectangulars that have been crossed. So in, there, is, no, do not really tell us anything about what the document is about, whereas nouns like theory, difference, practice do. And then in the first step, after these initial processes are done, we are left with theory, difference, and practice. After that, we need to indicate how important each of these words is to tell us what the document is about. And to that purpose, we assign a number to each word, based on different heuristics. Often taken into account is how often the word appears in the document, but also how often it appears in the entire collection of documents. Because if it appears very often in the entire collection, then it won't be very specific to that one document, as we know from the principle of indexing specificity that we need to follow when assigning controlled index terms. A very common weighting scheme is called TF-IDF. TF, term frequency, so the number of times a term occurs in a document, and IDF, inverse document frequency, the number of documents that contain that term. So these are put in relation. And there are hundreds of variants of this today, and we can really look at our example. But first, looking at the formula, the TF part of TF-IDF is really the number of times the term T appears in the current document divided by the same plus K. And K is heuristically derived parameter, so a number that indicates something. It can indicate, for example, if the term is found in title, it should be given a higher weight. If it's found in the middle of a long book and only there, then it should have a different weight. But often K is really a parameter determined to reflect the document length. So if you have documents of different length in the collection, you can take that into account. So back to our example, let's say we have three concepts here: theory, difference, and practice. Theory appears twice, practice appears twice, and difference appears once. So 2 for theory divided by 2 plus 1, which is 3. And the final weight is a bit higher for the words which appear twice compared to the word which appears once. That is then put into relation with inverse document frequency, which is essentially the number of documents in the collection divided by the number of documents in which the term can be found. So the IDF of terms that appear in fewer documents will be higher, so that the total term weight when TF and IDF are calculated together will be higher. Now, we talked a little about the very basic process of trying to automate what the topic is about. In reality, the approaches are much more complex, but in essence, this is what we try to kind of do with the text. Now let's look at something that we're much more familiar with, and that is the problems of natural language. We know that natural language is full of synonyms, homonyms, related terms, and just to remind ourselves that these are also important aspects when we are choosing an automated approach, which we will get to in a moment after we look at the different ways to deal with natural language problems in libraries, museums, and related institutions. So as we know, if you write the term Macedonia, it can refer to several different things, the most common ones being the Republic of North Macedonia, which took a while to get that name, was referred to the former Yugoslav Republic before. Then we have the geographic region of Macedonia. From antique times till today, it also includes parts of Albania, Bulgaria, parts of Greece, parts of Serbia, as well as North Macedonia. And then we have the Greek region of Macedonia. So if we write the term Macedonia in a full text search engine without controlled terms, we will get, in this example from yesterday, 375 million results, which really do not offer us any disambiguation mechanisms. And also, even if they did, it would still be too high recall for users to find that useful, depending on their use tasks. But let's put that in comparison to what we offer with subject headings. Here in Library of Congress subject headings, when we write Macedonia, then we get disambiguation. Here we see 2 examples of Macedonia as being the ancient country and kingdom. versus Macedonia and Greece. In addition, if we look at the first one, each of the aspects of Macedonia is further added. And in parentheses here, we see the number of documents assigned into that category, which is much more manageable, user-friendly, and the reason why we do controlled subject indexing in the first place in libraries. This is also referred to as assigned indexing, whereby we conduct semantic analysis, content analysis, and assigned terms from a controlled vocabulary classification scheme. And the former really belongs to derived indexing, meaning the words are derived directly from the text. The reason why I'm talking about this, because it's linked also to approaches to automated classification. And just to clarify this a bit more, so if the keywords or terms come from the text itself, that's known as derived indexing. If, on the other hand, they come from controlled vocabularies like thesauri, subject heading systems, or even classification systems, that's assigned indexing word classification. And in this case, assigned indexing is most often conducted by trained information professionals following indexing policies and standards like the ISO standard from 1985 for a subject analysis and indexing. But also it is possible that end users or some kind of users apply tags either from folksonomies of tags created before by other end users or from what we saw before in that piece of work from 2014, we created them, we offered them a list of semi-automated solutions from duodecimal classification and Library of Congress subject heading. So in that sense, that could also be considered assigned indexing. Okay, now the reason we talked about it, because it's important to understand the differences between approaches in automated subject indexing and classification. There are different ways in which we can categorize the approaches. The way they're categorized here is with the mind of their application for libraries. A most common research approach is called often text categorization, although you will find other terms for each of these approaches in the literature. And text categorization is essentially a supervised machine learning approach, which is a assigned indexing approach, where we have some kind of lists of terms or even controlled vocabularies into which then the documents are automatically classified. This approach requires, however, training documents, which means documents that are already pre-indexed or pre-classified, in order to then compare the new documents against those that are already with the right class or index term. Now, that is all fine in experimental setups, in test collections, in vocabularies which have a limited number of terms, but it becomes complicated in systems where we have 14,000 classes, like with duodecimal classification system, which would then require at least 1,000 classes for training, which is what some machine learning algorithms are asking for. And we do know that we do not have 1,000 examples for each single class in most libraries, or even within one country for one language, especially smaller languages like the Nordic ones. So that is text categorization. The second approach is document clustering, where which is really derived indexing, and even the names of classes are derived therefore automatically, and relationships between these classes. Let's say that this is an example of that. And that is not considered very useful for library catalogs, because users will not find it very stable that these clusters change every time they come back, because these clusters and relationships between them change as new documents are added. Also, research has shown that there is quite a big step of being able to automate really good class names and especially relationships between them. And finally, we have an approach called document classification. Although this is really not a common term in the literature, this is really not a common approach at all. But this approach does not necessarily require training documents or doesn't conduct machine learning, but instead conducts simple string matching between the terms. So this is also assigned indexing between the terms in target controlled vocabularies and the documents to be indexed or classified. And the way that it does it is by taking the advantage of the intellectual effort that has gone into creating the controlled vocabularies or classification systems. Because we already have sort of a background for artificial intelligence, if we want it like that. We have already crafted the basis of this, let's say, expert system, in that we have identified a lot of relationships, broader terms, narrow terms, synonyms, and all the hierarchies in the classification systems and some thesauri. And we can try to reuse that, especially in cases such as operational systems with large number of classes or index terms when we do not have training documents, enough at least. So we can compare them a bit further alongside different facets. So essentially, the first approach is the most common one in research, but it does require a lot of training documents, which we don't always have or often have for a large number of cases in libraries. Document clustering is the only approach that is derived indexing, and it is really considered better for other purposes, such as grouping web search results, perhaps, rather than for ensuring stable information services. But text categorization and the third approach, which are called here document classification, could be useful. Another problem with text categorization is, although it's a highly researched approach, the way it's being evaluated is on established test collections conducted outside of context, and it has also been shown that even small variations in these test collections result in very different results or different enough. So also they usually work with a smaller number of assigned indexing, a smaller number of controlled vocabulary terms, much smaller than is typical in the library, archives, and museums collections. What is common to all of them is that they all suffer from evaluation issues that we'll come back to in a moment, as well as one of the challenges. To finalize this background overview, just a few examples of the tools that are freely available. uClassify, uclassify.com is the address, uses demos, what used to be a directory of websites, and the classification they used is called demos classification tree. And you can simply enter copy-pasted text or URL in various subject areas, and it produces results. Another freely available tool is Annif, and you may have heard of it because there are discussions and other libraries are actually using that. It's maintained by the Finnish National Library, and it allows, what is really good about it is that allows any controlled vocabulary, as long as it's available in classe format, to be used with it. So if you have, most vocabularies are being available as classe today or are about to become that, and then it's relatively easy to plug into this software. And this software is also possible to combine several different algorithms, from text categorization or supervised machine learning, but also string matching. So in the case of the lack of enough training documents, we can apply the string matching approach using this software. So in short or long, this was the background, also the longest section in this talk. We looked at the possible uses of automated subject indexing and classification and different approaches. We have also seen some of the challenges, and let's look at those and a few more here. The first group of challenges is about theoretical problems. We start with the assumption that concepts are always given names in documents, which is certainly more common in natural sciences than humanities, where language is often on purpose metaphorical, which presents problems for automation. Also, a subject is considered to be a string occurring above a certain frequency, is not a stop word, and is in a given location, such as title, because we said before the TF-IDF weighting scheme can be adjusted so that higher weight is given to words found in title or abstract compared to those in the middle of a book, for example. Again, this is problematic because think of humanities text, this would not really work that well. Also, in algorithms, inferences are made such as if document A is on a subject X, then if document B is sufficiently similar to document A, for example, based on a comparison in machine learning, or if they share similar words or references identified in some other way, then document B is also on that subject. When we talk about machine learning, we represent documents and the target index terms as vectors in a mathematical vector space model. And then how similar to documents are in content-wise is computed based on how far away or how close in the vector space model they are, using measures like the typical cosine measure, if we remember from our basic mathematics in vectors. And again, this is not quite theoretically justified because there is much more to semantics. Also, how much can we really trust the algorithms? We really need critical methods to understand both how the data are generated and processed, both the input data as well as the resulting results. We really need to open up the complexity of the black box of algorithms, especially in machine learning. Because if we have string matching, as in the third approach, then it's easy to see why we were successful or unsuccessful. But with machine learning, often, especially with some algorithms, really the only way to improve the output is to increase training documents. But how really the different factors come into interplay is hard to see. And here we see another example which may illustrate some of the dangers of taking automatic solutions for granted, is that actually the number of films Nicolas Cage appeared in correlates with the number of people who drowned by falling into a swimming pool. And now you will see even some sites blaming Nicolas Cage, but it's not a causation relationship. It's not that one caused the other. It's just simply correlation that somehow somebody managed to notice. But then this is obvious, but other examples would not be so obvious, especially if we're getting results by the algorithm that we like. All this brings us to another challenge, and that is that the reported success of automated tools is really unknown. Okay, some state that it's possible to entirely replace manual indexing, but that largely depends on the context. If we are working with text collections in text categorization and not for operative information systems, but some smaller or different scenarios where we only need a small number of target terms and have enough training documents, perhaps it's good enough. And it is good enough for spam filtering in email, for example. That works pretty well, and it would be really hard to do without. But when it comes to large operational systems like library catalogs with a lot of classes, a lot of terms, these results range from 50 to 60% accuracy, which isn't that much because it's almost close to random, to a bit higher. So in conclusion, really, what we can do today is apply machine-aided indexing or semi-automated indexing, as is also well applied by the US National Library of Medicine, who use medical text indexer, which is a very well-researched machine-aided indexing tool. They use it to provide a quicker index terms and to deal with a large number of digital documents that are also increasing, as well as have some other benefits, like some kind of consistency has been also researched. But this also brings us to the problem that we already mentioned, and that's connected to evaluation. Really, research comparing automated versus manual indexing is problematic. Set 20 years ago or so, but it's still the case because still most of research is conducted out of context in laboratory conditions. As we have seen with the example of text categorization, who still conduct most of their research using these text collections. And there are very few reports on indexing tools in operating information systems. We'll come back to ways that try to address it in some way. But before we do that, okay, let's do that. So we have conducted a project that proposed a framework for evaluation. And that framework is rather comprehensive and includes 3 components in order to be able to evaluate indexing quality. One is by comparison with the gold standard, but that gold standard should also be carefully crafted rather than just take what is out there, or what also is sometimes case, you pay students to decide whether something is on a topic or not. Another step is also to look at an indexing workflow and use semi-automatic indexing software and see what kind of decisions are made and try to understand why. And finally, since the purpose of subject indexing is improved information retrieval, then also analyze the results during retrieval. There is a lot more to say on this, and I'm happy to talk more about it during the discussion. Before we go on to the following section, there is one more problem that we are probably aware of before, but it's good to bear in mind, especially when we want to consider that derived indexing or semi-automatic solutions, as well as social tagging or end user's perspective, should be used to further complement what we do with just manual indexing based on established controlled vocabularies or classification systems. And that is that classification and indexing isn't always only representing information, but sometimes it's also creating it. Extreme example is if we look at Library of Congress subject headings, how they have treated homosexuality throughout history in a way that reflected what the American Psychological Association was saying, but then it was still in effect creating information. Another example is the fact that up until more recently, it was not possible to search Library of Congress subject headings using the term Vietnamese War because the war was never proclaimed. Instead, you had to write Vietnamese conflict to get any results. Well, another a bit harder to discern example is if we compare DDC, Geodecimal Classification, with Swedish National Classification System that was recently replaced by DDC. It's interesting to see that DDC looks at leadership as social control through specific models, and that is not at all present in SAB. So it's also a way of viewing leadership that comes from another part of the world. Anyway, this is just really to illustrate the need that we actually may need other perspectives than the ones that are included in controlled vocabularies, and full text indexing, full text retrieval, as well as derived indexing automatically, and social tagging would help with that. So having looked at the challenges, we can look at some key implications. Why do we need automatic subject indexing or classification? Well, we are facing more and more digital documents in our collections, and in order to maintain the bibliographic objectives and providing high quality subject access, it could be a way to address the problem of scale and sustainability. Also, this problematic subject access to especially new digital collections could be addressed not just by automatic subject indexing conducted by catalog librarians, but also by authors for repositories and by end users if end user social tagging is supported. Also, similar methods can be applied for research. So there is certainly potential when it comes to application, and semi-automated means are really the way forward. However, it's still a big research agenda to have comprehensive evaluation conducted in operative systems. And we also need critical methods to understand the processes behind, both in terms of subject indexing and research. Because as much as we said that subject indexing needs to be only semi-automated rather than fully automated, all things concerned. Similarly, when it comes to research, when we do information literacy or data literacy education for our users, it's important to emphasize that automated methods are meant to help interpret and understand the data. But it's still the scholar's job to do the actual interpreting and understanding. Finally, it is my conclusion that it's best to combine manual, but also semi-automated as well as end-user indexing and author indexing. It is to develop and test evaluation methods further and to provide training to scholars, both on automated topic identification and critical methods. With this, we have covered some of the basics of what it means to conduct automatic subject indexing, how it can be applied, what are its challenges, and how we can apply it more responsibly. Now, let's finish this talk by looking at a case study, which really looked at the Swedish Union catalog records and tried to generate automatically created geodecimal classification classes. The ultimate purpose of this research to establish the value of automatically produced classes for Swedish digital collections. As we have seen, and we will show in a moment, many of them lack any subject access. Specifically, we aimed to develop and evaluate approach to automatic subject classification for Swedish textual resources based on the Swedish Union catalog. The data set included over 140,000 catalog records that were all that contained DDC at the time. That was done in 2018, and we're still working on it, like the results, unfortunately, to be able to present for you today. And here we actually used the most common approach to text categorization, and that's machine learning, supervised machine learning. Specifically, two algorithms were applied, naive Bayes and support vector machine. Now, the rationale is really the lack of subject classes, the lack of subject index terms from controlled vocabularies in new digital collections, such as Alvin, which is platform for digitized cultural heritage. If we look at the extended search and we look under subject, that's it. It's just a field. There is no possibility to use the tools such as word sense disambiguation, broader terms, narrow terms to help with precision and recall. It's likely that there are no controlled vocabularies at all, and likely the reason for that is the lack of resources. Sendera is an interesting example which tries to combine libris that has controlled vocabularies, quite a few of them actually, but when put together with National Archives or Swedish Media Database, In advanced search, we don't have much. We just have a free keyword search, which automatically diminishes completely all the effort that has gone into creating all the subject terms in libraries. A third example is SWEPA, which is a national collection of all university repositories. Here, if we look under keywords, we can search. Keywords are title, author, subject, etc. So nothing of what we can do of the advantages of controlled vocabulary-based searching. We only have a short list of categories of disciplines. Also, another reason that focused on DDC was that Sweden switched from SAB to DDC in 2013. And DDC is de facto almost international classification scheme, which is most widely used of all classification schemes. And then since the numbers are the same in all languages, it's really easy to do cross-lingual search and further make Swedish resources visible, etc. So there are these other ultimate purposes also. So how we went about it is that we received the 23rd edition of DDC in marked XML format. Since it was so well formatted, it was easy to extract relevant information. And that was the class number, heading, relative index terms, as well as different notes. The data collection was mentioned earlier, of the catalog records that had DDC at the time. And they were really a challenging problem for this research because they're very short text, but they do have keywords which already summarize the content of the document well. When we first looked at the sample, we thought, oh, great, 140,000 records, that's a lot. But then we forgot to measure that against the 14,000 classes that DDC has. And trying to get 1,000 records per class was not really possible. And this is why we had to truncate the long specific DDC classes into only the top 3 levels, which again is an example of how we can talk about the wonders of automatic approaches and artificial intelligence, but in reality, there are things that need to be taken into account and addressed in some way. So the training problem was there not just because if we would divide 140,000 of records by 14,000 classes, but also because many classes had less than 100 records, and some classes had even 20,000 records. And if we look at research of others who have done similar with large classification systems like DDC or UGC, they have found the same problem. The imbalance is very big. How we went about it more specifically, the pre-processing was identifying the words, applying TF-IDF scores, and then we used 2 different algorithms known in text categorization community. There are many different evaluation measures one can also use. The simplest one is dividing the number of correctly classified examples by the total number of examples, and that's called accuracy. But actually, it will be good to take into account some other aspects and look at partial matching. And there are many measures to do that as well. We had almost no resources to do this research, so that's one of the reasons why we didn't go as we wanted to. It turned out that SVM performed better than naive Bayes, and 80% of accuracy was achieved for classes that had enough training examples, but in reality, we don't have that, and then we have some 60% accuracy. In the future, we need more training examples, and 3 years have passed since, and we are now actually working with a much larger set. And we also want to support full DDC classes, not just the top 3 levels, in order to make them meaningful for use in operative information systems. Also, for the lack of training, we plan to use string matching or the third approach from our table called document classification to take advantage of the vast hierarchies of DPC as well as related index and synonyms. And certainly this involves real-life testing, which I'll be happy to talk about more in the discussion. But with this, I have reached the end of the talk. We have looked at the whys and the hows with some challenges and shown an example of how it can look like in one of the Nordic countries kind of cases. There are also some references here, and if there are any questions, I'd be more than happy to answer them. Suggestions as well, always more than welcome also for collaboration.